Hello everyone, my name is Kirill and I work as staff mobile engineer at Muse. And as I usually say, staff engineer is too vague of a title, so what they do usually differs from company to company and even from department to department. So in my case, it means that I don't belong to any specific team. I usually help other engineers and other teams with things like code reviews, architectural decisions, and some ad hoc issues. Also, I sometimes consult other companies and startups, review their code, and mentor their teams. So I see different approaches to ARP architectures and what these approaches lead to. And today I would like to talk about how to make your architecture a little bit simpler, but at the same time, maybe more reliable and manageable. First of all, let's agree on what is the app architecture. But even before that, let's talk about what is not an app architecture. Usually, when I'm introduced to a new app, I'm asking the team to describe their current architecture. And I often receive responses like, well, it's block or riverpod or MVVM architecture. The problem is that this is not app architecture. Block and riverpod are state management tools. MVVM is an architectural pattern for the presentational layer, but they do not define your app architecture. Yes, all of them can be pretty important architectural decisions that you make throughout the app development, but they do not describe your app from the architectural point of view. Sometimes I got answers like, we have a solid-based architecture. Again, it doesn't tell me anything about your app. Solid is a set of principles. They can be useful, actually not always, as we will discuss later, but it's not the representation of your app architecture. Another popular response is, we have clean architecture. And you can say, well, this is exactly it, right? It's even called architecture. There are several problems with that. First, it still doesn't say that much about your app. Even if applied correctly, clean architecture is not the app architecture. It's a set of principles to build your app architecture. And this principle can reside in an endless number of different architectures. Second, I often see many implementations of clean architecture in different tutorials and real-life projects that, from my point of view, don't follow its core principles. A third, the strict approach to clean architecture doesn't work well with Flutter apps. I was talking about it in this article, but long story short, it's speaking about the whole software system, where mobile part would just be a part of it. And it focuses too much on things like separate deployments. It's also very defensive about business logic. And guess what? The vast majority of mobile apps don't have business logic at all. But more on this later. So returning to our question, what is architecture? But before answering that question, let's talk about the goal of software architecture. I like this definition by Robert Martin in his Clean Architecture book. The goal of software architecture is to minimize the human resources required to build and maintain the required system. And the most important part here is maintain. We rarely create apps that aren't supposed to be maintained in the future. And when we do, they usually require a totally different approach to architecture. But the majority of the apps are long-lived. And maintenance, which includes both fixing bugs and adding new features, is the biggest part of the app lifecycle. So it makes it extremely important to make this part as easy as possible. Okay, let's finally answer the question. What is app architecture? We can find pretty good definition in Wikipedia. Software architecture is the set of structures needed to reason about a software system and the discipline of creating such structures and systems. Each structure comprises software elements, relations among them, and properties of both elements and relations. Many tutorials talk about components and their properties, but relations are often described only from the layers point of view and miss very important part of relations between components. Let's start with components as well, but later we will focus on relations. Within the scope of this presentation, I would mean roughly the same by components, features, modules, and I like this definition by Simon Brown. Component is a grouping of related functionality behind nice clean interface, which resides inside an execution environment like an application. So speaking about the components in the app, they are not screens. Although screen can be a part of the component, but it's not required. They are not user flows, at least not necessarily. Something like user registration flow can be a separate component, but that doesn't mean that components should be divided exclusively by user flows. In the similar manner, components are not necessarily some global responsibilities. It doesn't mean that authentication, for example, should be a separate component and everything related to the authentication should go there. It's better to think about components from the loose coupling, high cohesion point of view. Everything inside the module should have closely related functionality. And at the same time, outside connections should be kept minimal. And also, the module should be properly encapsulated. Other components shouldn't really care about the implementation details of the specific model, and basically they should treat it just as a black box. So let's take a look at what can be inside of the component. As long as you follow the rules about the encapsulation and loose coupling and high cohesion, it actually doesn't matter that much. This is just an example of the structure I usually use in my projects. Screens is a top-level layer and the first and best candidate to be used by other components. If you can use the whole screen from another module, that's great. You don't care about its implementation. It's a proper black box. A screen consists of widgets, and this is the next layer. But widgets are not some dumb view components. We'll talk about it in a minute. And next layer is services layer. Some call it business logic layer, but I don't like it. As I mentioned before, the majority of the apps don't have business logic at all, because business logic is not about communication with backend. It's not about user authentication or client-side form validation. Business logic is the set of rules that define how your business objects communicate with one another. And pretty much it most probably will sit only on the backend. So in this layered scheme, services usually do what would be better described as application logic. Something that's more or less abstracted from the UI and from the implementation of things like data sending and receiving, but it's still specific about your app. So state management patterns like block or report, they would typically belong here. Next is the data layer. And this is implementation of repository and API clients. I prefer to keep them as simple and straightforward as possible. This is what you would usually mock in your test or provide some test implementation. So you really don't want to have any complex logic there. And finally, the models layer. But again, keep in mind that not all the models go there. Only the ones that are shared between the different parts of the module or between different modules. Although I typically discourage from doing that. But if the only use case of the model is to be returned by a repository or service, then it's better to put it closer to the corresponding class in the same file. And they usually are not rich domain models. In the majority of cases, they are just data holders. And as I mentioned, widgets are not some dumb view components. Some developers split them into model views and views, but I usually advise again that I find MVVM in Flutter rather an anti-pattern, and I was talking about it in this video. Do we need all the layers in each module? Definitely not. Avoid adding abstractions if this abstraction doesn't encapsulate any logic. If your service just proxies the call to the repository, then you don't need it. Let the widget directly call the repository. And yes, layers can communicate with any lower layer, not with their direct child. And out of practice, in many cases, you will just have a couple of layers, like widgets and services in the model, or widgets and data. But the direction of these dependencies should be one way only, from top to the bottom. And by the way, the good thing is that you can, if you're using Dart code metric static analyzer, you can actually set it up in the way that it will forbid you from breaking this dependency direction. So it will forbid you from, let's say, importing widgets folder in your data folder or services folder. And if you notice one more thing about these layers, there is no dependency inversion with this common implementation. Here, services layer calls data layer directly. And yeah, I know this is terrible, but let's talk about why we need this principle. In general, it allows us to depend on interface rather than implementation, right? But in Dart, every class already defines an interface implicitly. Well, yeah, there is this new base modifier that basically switches off the interface, but if you're using it explicitly, well, you're supposed to know what you're doing. Anyway, with implicit interface, there is no problem at all to have another implementation of the class and just, let's say, provide it in tests. And tests are the major consumer of such cases. But this is just another abstraction that if you use it in a wrong way, it will just make it more complex, and it reduces this non-natural way of thinking. And by the way, it doesn't mean that you should never separate interfaces. It actually can be pretty useful when combined with, for example, with interface segregation principle. But avoid having a separate class if avoid having a separate interface if you have only one implementation of it in your code in some other part. Well, this is the common case of people defining the interface, and then there is the class implementing this interface with impulse suffix. That basically a yellow flag that shows, well, you probably don't need this interface at all. And one more note about block. Does it always belong to service layer? And the answer is it depends. The block as a library is just an implementation of finite state machine pattern. If you use it to handle the application logic, it will be sitting somewhere in the services folder. If you keep some complex UI state there, well, that will be a part of widgets layer. But asking whether block is a service or UI, it's basically the same as asking if singleton is that data layer or whether I should use factory only in widgets. And since we started talking about dependency inversion principles, let's discuss other principles as well, other solid principles. Single responsibility principle. I think this is the most misinterpreted principle with very confusing naming. Many people think it's about class or function or model, etc. should only do one thing. In Clean Architecture book, Robert Martin already discussed it. The principle is rather about one reason to change or like responsibility to only one actor. And from this point of view, it's more about grouping the related functionality together, and it's similar to what loose coupling and high cohesion principle talks about. And from this point of view, it's extremely valuable. It's basically the main principle of how you structure your models in the app. Open-closed principle. Software, entities, classes, modules, functions, etc. should be open for extension, but closed for modification. Partially, on a module level, it says about stable and extensible API. But the point is, not all your components should actually be stable, either from the product point of view and you're changing them often, changing like in the overall behavior of the model, or remove the model completely, or from the dependencies point of view. Liskov substitution principle. It's a very important principle if we talk about class hierarchies, and it's actually pretty complex to follow it everywhere. But I would say the inheritance itself is pretty complex topics, and in general it should rather be avoided. Interface segregation principle. This is the only principle where I don't have any buts, almost. It's very useful if your code don't depend on the things that it basically doesn't use, that the system is easier to understand, to maintain, to reason about. But it can lead to more boilerplate. Any class with more than one client or with more than one method, for example, repository or API client, will most probably violate this principle. So again, it just be reasonable. And we already discussed dependency inversion principle. One thing to add here is that I vote against applying dependency inversion principle only when speaking about layers in the component. It can be highly useful when we deal with stability and flexibility of the components, but we'll talk about it later. Right now, again, just remember that these principles shouldn't be applied everywhere just because you can. And yeah, basically, violating any of these principles is neither good nor bad. It's all about why is it violated, or if you want, why it should be applied. And if you can answer this question, then it basically doesn't matter that much if you follow this principle or not. And what about dry principle? And by the way, the reason that I've chosen solid and dry out of so many principles out there is that basically every second job vacancy I see is mentioning about a good understanding of solid, dry, and clean architecture. So it's already becoming an IDEA fix. But anyway, dry principle together with single responsibility principle is one of the most misinterpreted ones. And again, the problem is maybe in the very confusing naming. It's not about repeating the code per se. It's about keeping a single source of truth in your logic. And tellingly, people tend to describe wet principle or write everything twice as the opposite principle of dry. But that exactly shows the misinterpretation of the dry principle. It doesn't matter how many times the repetition occurred. If it's repetition of the logic or of the knowledge, then it should be avoided. If it's just a repetition of, let's say, creating the same widget in many places with the same parameters, it doesn't necessarily mean that you need to introduce some wrapping widget. Okay, now as we talk about components and relations between different parts of the component, let's switch to more interesting and less discussed topic of relations between components. And this is usually what I want to hear when I ask about your app architecture, how your components interact with each other. As this is the main characteristic of your app that can say whether it's a big ball of mud or a properly structured, easy to understand and maintain software. And it also allows, even without looking into the code, to understand what actually your app is doing. Take a look at these two pictures. The left one describes some general architecture, or as we discussed previously, some principles that can be used to create an application architecture. It doesn't tell me anything about your app. The right one describes an architecture of the specific app. It's much more informative if you want to understand what your app is about and how it is built. So what can it tell us? By the way, you can find the source code of the application following the link in the QR code. But just looking at the components graph, we can say that the app has something to do with movies, favorites, search, and profile. So most probably it's some movie search app that allows you to create a list of your favorite movies. But what about the components themselves? If we take a look at content module, we can see that it doesn't depend on any other component. So what does it mean? First, it should be easily testable. Since it doesn't depend on anything else, it doesn't matter if there is complete mess in the rest of your app. We can just take this component and test it in isolation. But at the same time, a lot of other components depend on it. So if you change something in this module, well, it can cause some changes in its direct dependencies, like favorites or search module, which in their own turn can trigger changes in their corresponding dependence, like home or dashboard. So if you plan some big refactoring of content module, well, you better be prepared to change half of your app. And this is what's usually called stable component, something where we don't want API to change a lot and to change frequently. And it's also independent because, well, it doesn't depend on anything else. And vice versa. If we take a dashboard component, we can see that no other components depend on it. And such component is called irresponsible. And since no other components depend on it, it's very safe to change. We won't break any other component. And this makes it very unstable. At the same time, dashboard component depends on every other component in the system, either directly or transitively. Without some proper abstractions, it could be a nightmare to cover the component with tests. Or maybe not. Most probably this component is just an entry point to the rest of the app, so it actually can be a good candidate to cover with end-to-end or integration tests. So, without even looking at the code, we've gained a lot of insights about the app. What's its functionality? What parts are easier to cover with tests? What components could be hard to change, etc. But what else should we pay attention to when dealing with such a graph? One of the most important things to look for is the absence of cycles. Your dependencies should form a directed acyclic graph. Why is it important? Having cycles turns modules within a cycle into one big module. If you have profile module depending on auth module, and auth module depends on dashboard module, which in its own turn depends again on profile module, it means that you have one big module. You cannot use these modules separately. You cannot test them separately. So it's just one big module, auth, dashboard, profile. And changes in one module will most likely lead to changes in two other modules. Another moment is to check for loose coupling and high cohesion principle again. We already discussed it before. This is the nature of the modules, and you can easily spot it on the graph. If you have few errors inside of the module and a lot of errors going from one module to another, then most probably you are violating the principle. To fix that, one of the options would be to rearrange files in the modules. Remember, the modules are not grouped by use case or by screen in the app or by the UI hierarchy. It's exactly about keeping highly cohesive functionality together. And we've talked about what should be a structure, what to pay attention to. So let's now talk about how we can watch it. What tools allow to build such graphs, how they can help to ensure that at least some of these principles are not violated. For the total graph of all relations between files, I usually use Lakos library. But as you see, even for a very small sample project, the graph looks scary and messy. But good news is that you don't usually need to check it manually. Lakos can report if there are cycles in the graph. So in the majority of cases, you are only interested in this is acyclic true outcome. And yes, even that you don't need to check manually. Lakos can be set up in the way that it will return an error if there are cycles detected. And since it doesn't perform the actual static analysis of your Dart code, it just parses import statements in the files. It works very fast. So you can just set it up to run as a part of your CI/CD checks. But when it comes to something more complex, like grouping the files into modules, here comes again Dart code metrics static analyzer with its new analyze structure command. Well, keep in mind that this command is right now in early preview, so not all the functionality is there. There can be some break-in changes, but even now it allows us to build this component graph, where it groups all the dependencies within the components. Unfortunately, currently it's not able to provide you with this report and check for the cycles automatically, but at least the components graph is usually much simpler than the full graph of all the files. So in the worst case, you can check it manually, or you can just run a script on the graphviz file that DCM produces and check whether there are cycles there. And keep in mind that it's actually important to check both, check whether there are cycles in both full graph and the components graph, because it can happen that one graph is acyclic and another one isn't. And to sum it up, what are the benefits of this approach? First, it's flexibility. You have more or less independent modules and you actually focus on that. So it's easier to split the work between developers or to make independent changes. Second, transparency. You have an overview of stable and unstable components, so you can plan things like refactorings. You have an idea of what components would be easier to cover with tests, which ones are dangerous to be changed. Third, it's maintainability. As the second law of thermodynamics says, entropy of any isolated or closed system will always increase, or at least stay the same. So without constant maintenance efforts, the chaos will increase. But at least with this approach, chaos can be kept locally. Whatever messy one module is, ideally, it shouldn't affect that much other modules. And next, and very important point, simplicity. Do not introduce unnecessary abstractions. Do not focus on multiple layers for the sake of just having these layers. Keep things simple. And instead concentrate on relations between your modules. This is something that should be done anyway, so just start with it. And litmus test to check whether your abstraction is necessary or not is ask yourself a question. Why did you add it? And if you start answering with, well, in the future, then stop, you don't need it. And by the way, saying it's cleaner, it's not an answer as well. And this all leads to better scalability. As you have decomposed system and you see its strong and weak points, you can strategically target these weak points and evolve the system. Or if your system grows further, if it grows larger, you can easily switch to something like modular architecture, where a group of your components would be easily extractable to some external model, external dependency, even like some external package. And when I was rehearsing my presentation, I've got a comment from someone like, this looks a lot like clean architecture. So is it really an alternative to clean architecture, or is it just the same reskinned idea? And well, yes and no. Throughout my presentation, I was referring to clean architecture as to something I see a lot in tutorials and real-life projects, where developers take some sample implementation from the original articles and make a literal transfer to the Flutter app. I rather vote for implementing ideas of clean architecture, like clear boundaries, well-defined dependencies, isolation of the modules, and plus always being a little bit skeptical and a lot pragmatical. From that point of view, I think this is even closer to the original ideas of clean architecture than just some blind repetition of use case, presenter, repository, data source classes, blah, 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 from project to project. And the main visual differences from these most popular implementations are simplification. So instead of this like traditional hierarchy of all these abstractions and classes, just be pragmatic, do this. You can always add more abstractions later. It's always easier to make it more complex than more simpler. And inversion of dependency inversion, or just dependencies. Again, not always, but pretty often you don't need this another abstraction that does nothing and just sits there in your code. And also structure by components, where components are defined by their cohesion. It's a good starting point to just introduce the components to your system. Keep your components as small as possible, so it's just easier to manage them. It's easy to regroup them again later. You can combine them together and extract to a separate package. And focus instead on components relations. And that's it. If you have any questions, feel free to ask them now or reach me out after the presentation. Thank you.